Okay, so this is number 4. How much energy is transferred when 50.0 grams of water is formed from the combustion of C6H6? So every time you're combusting, you will take the fuel, which is C6H6, that's the hydrocarbon, and you're going to add that to oxygen. That's in a combustion reaction. And you make the same products, which are CO2 and H2O. Okay, before you do this reaction, you have to balance it first. So you have 6 carbons, so I'm going to put 6 right here. I have 6 hydrogens, so I'm going to put a 3 right here. Now I have 6 times 2 is 12 oxygens plus 3, that makes 15. I'm going to put 7.5 as half of 15. Okay, because you can't have halves, I'm going to go ahead and double it. This used to be 1, so I'm going to double the whole equation. So that's 2, 15, 12, and 6. So that is the balanced equation. So when they say how much energy is transferred when 50 grams of water, so you have 50 grams of water, which is right here. But you need to know the delta H for this whole reaction before you do that. Okay. So to get that, you have to find the heats of formation for each one. So I'm going to go ahead and look at the thermodynamic data. This is also in your calendar. Just click right here where it says thermochemical equations. Okay, so I'm going to look up C6H6 under carbon. It's right here. I circled it, 49.0. I also looked up CO2, and hydrogen is right here. And no, I don't need hydrogen. I'm sorry. I need water. So it should be under oxygen. Water should be under oxygen. So right here, water, I'm going to use the gas right here. Okay, I'm not going to be using oxygen. Okay, so you take all those values and you will write them right underneath. So you have 49.0, and the units are kilojoules per mole. This is 0 heat of formation. CO2 is negative 393.5. H2O is, by the way, these are all gases. Gas, 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 and except for C6H6 is liquid. Okay, and then this one is negative 241.8. Don't worry so much about the sig figs. I'm just going to round it to 3 sig figs in the end. Okay, so I'm only putting the units for the first one so you can see how the units work. The 2 means there are 2 moles, so you're going to multiply this whole thing by 2 moles. As a result, the moles will cancel and you will have the answer in kilojoules. You're going to add this, and then these are the reactants. And then for the products, you're going to multiply this by 12, and you're going to add this multiplied by 6 because of the 6 right here. Okay. When I did the math, all of these was negative 6,172.8. And then this is 98.0. Okay, so the heat of the chemical reaction is equal to products, which are, these are the products, right? Minus reactants. The heat of formation of the products minus reactants equals, products is negative 6,172.8. Okay, that's the product, minus the reactant is this one right here. This goes here, so 98.0. Okay. The units obviously will be in kilojoules because the moles cancel. So this is kilojoules. This is kilojoules. So the answer would be negative 6,271 kilojoules. Okay. So because the moles got canceled, I'm going to go ahead and call this kilojoules for every one of this chemical reaction. For every reaction. Which means this is the heat evolved when you have one chemical reaction, which means this is the heat evolved when you have 6 moles of water, 12 moles of CO2, 15 moles of O2, and 2 moles of C6H6. Okay, once you have that number, that is the delta H of this chemical reaction. If you wanted to get the energy transferred, if you only have 50 grams of water, then you have to do a little bit of stoichiometry. So what I will do is I will go ahead and change the 50 grams of H2O to moles. 1 mole of water is 18.02 grams. Okay. According to this thermochemical equation, do you see the 6 right here? Okay, that means for every 6 moles of water, this much energy is evolved. 6,000 negative 6,271 kilojoules. Okay. And so when you do that math, you're going to get the answer 2,000 negative 2,900 kilojoules evolved. Okay, and that's how you do it.